time to go back and answer homework questions and everything else since it was just in behavior. I'm going to keep moving forward so we can finish this whole sheet, and then tomorrow we'll answer questions on the whole shebang. So let me finish. This is more polynomial analysis. Oh my gosh. Get it together, Stacy. Get it together. Oh man, it's been crazy. Just a crazy week, I think. Okay. This is continued. By the way, if you're in desk store with me, don't forget we have a meeting today.
I saw that.
You saw what? Oh. All right, so listen, we're going to take these funky polynomials and we're going to do a little more analysis on it than what we were doing before. So before I show you how to do it on the calculator, I got to show you how to do it I got to show you what it looks like. This is where things get sticky, so pay attention and ask questions if you have them, okay? I'm going to put just a random polynomial here. What do you think that kind of polynomial is here? What does that look like? It looks like what kind of trinomial? A cubic, right? What clues you in that that's probably a cubic? The humps, right? The humps. I know it's odd because the ends are going in opposite directions. Do you think the leading coefficient here would be positive or negative? Y'all sure? Positive. Remember, if the right goes up and the left goes down, think about a line going uphill. It's a positive slope, positive leading coefficient, right? All right, and I know I'm standing backwards from you, all right? So it'd be like, anyway. All right, so we have some things within this polynomial, and they'll happen on, some of them you'll have and some of them you won't. We talked about end behavior yesterday. That's a biggie, okay? And that takes a little while to start getting in your brain. But we also have maximums and minimums. If you were looking on this graph, where do you think maxes or minimums happen? At the peaks of the humps, that almost like a vertex there if it was a parabola, right? Here and here. Does everybody agree with that? Uh-oh. What do you think this one would be, a max or min? Nope. What do you think this one would be? A min. Now, you didn't tell me the arrows on the end. They go forever, right? Don't do that, everybody. There's always a couple people in every class. Don't circle this and say max, because that's not what that is. That's not giving me a point. That's telling me that I go on forever and ever up, okay? Which brings me to my next point. How can you say that that's maximum whenever there's a point that's higher on the graph? It's the maximum just in that little area right there, right? Just in that area. It's not absolutely the maximum highest point on the graph. So I call it a relative max, because relative to the area that it's in, it's a maximum. There's a higher point somewhere, but in that particular area, it's a maximum. Does that make sense? Nope. It would be above it, but don't count it as a maximum. Yeah. This one, yes, this one would also be a relative minimum. Okay. Let's see if you really understand part of yesterday. When would it not be? So if it's not relative, I can have what we call an absolute max or min, which means there's no higher and no lower point on the graph. What kind of graphs would have an absolute max or min? A quadratic would. What else? For quadratic, what other kind of polynomial? Be more general for me. What you got? All of the evens. That's exactly right. Why all of the evens? Both ends are going in the same direction. If both ends go up, then it has an absolutely lowest point, right? Or if both ends go down, then I have an absolutely highest point, right? So quadratic, quartic, 6th degree, 8th degree, 10th degree, and so on and so forth would all have an absolute. So let me show you what that looks like. Yes, Harris, do you have a question? Okay, thank you. Appreciate that. Not necessarily, because what if I had this? I've got, what is this point? That's a max. Do you think it's relative or absolute? Why is it, those of you saying absolute, why is it absolute? There is nowhere on this graph that it ever goes above that line. That's the absolutely the highest point on the graph. But here, that is a high point, but just in that area, so it's relative. Oh, yeah. Can somebody run up front and grab a check? Me? I got it. Somebody who doesn't feel like they can catch back up. Oh my gosh. I don't like picking. I don't want to pick. And I didn't want to pick somebody to pick, but that's okay. Who'd you pick? Oh, go. The office, the front office. She's got a check for me. See why this is hard? It's even, so therefore it does have an absolute, but they're not all absolute. And we're going to talk about why. Yes. This one, relative min. Now let's talk about why this happens. We have, and this is another form of analysis. Remember I told you we have a bunch of steps. What you got, Gracie? Absolutely the highest point or absolutely the lowest point on the graph. And then the relative in that area is the highest. Yeah. No, I was just showing you. No. All right, let me go to a very basic here example to show you what I'm showing you next. All right. This is one you are very, very, very familiar with, yes? This is a quadratic, right? Does it have any maxes or mins? What? Absolute minimum, right? And I could actually find, I don't know, we just can, do people still do that?
I get like a senior one.
Like, I bought one in high school, Russell bought one in high school. We've never even, like, they sit in a jewelry box. We've never even worn them. I'll buy her a college ring, but not high school. You'll never wear them past high school. You'll wear them your senior year, but then you won't wear them past school. But you'll have to. Yeah. I didn't even buy a college one. All right, let's get back to this one. I'm sorry, that was an interruption. That was Coach Collins' fault. And I know he wrote it because it said, good morning, magnificent and glorious, something. All right, so we said this is absolute. Lane asked you a good question. Does it have to have those little stars on it? It doesn't. I was just trying to bring your attention to it. All right, so the next step of our analysis, and this would have a point, this would have coordinates. I'd say that this parabola has an absolute minimum at, and then I'd name whatever the point is here. And we're going to talk in just a minute about how to find them. Right now, I want to make sure you know what it is we're finding before we actually start finding. Now, how do we know where these humps happen? So as we move left to right, just like you read a book, right? You read a book left to right, you read a graph left to right. We have what we call increasing and decreasing intervals, which means as you move left to right, if it's increasing, the graph goes up. If it's decreasing, the graph goes down. So let me show you what I mean by that. We're going to name the increasing and decreasing intervals here. All right. No. I wrote that. No, you're reading from left to right. So as you move from left to right, is the graph going up or down? So start at the far left side of the graph. So let's pretend like I'm a little bug on here, right? As I move from the left to the right, is my bug going to have to go down or up? So my graph is decreasing. And in fact, it's decreasing all the way until I get to this one point right here. And what is that point? That's my absolute. So my graph is increasing. And by the way, we always describe this with x values. Let's just say, for instance, I'm gonna give this a coordinate, okay? I'm gonna give this a point. Let's say my absolute minimum was at 2, 5. My graph is decreasing from negative infinity, right? Because all the way from the left, remember I'm talking about x values. From negative infinity until what do you think? 2. Okay? Okay, but past that, what's it doing? When I get here, I stop decreasing and I start increasing. That's exactly right. So I'm increasing from 2 to infinity. Do you see how my bug stopped going down and started going up? He literally changed directions at that point. Yeah. No, we'll talk about what to use a little bit later. Right now, I'm just worried about these numbers, that you can find these numbers. So this, sometimes these maxes and mins we call turning points. Do you understand why we might call them a turning point? It stops increasing and starts decreasing, or vice versa. So you asked, does it always happen at a hump, and how can I tell? I can tell for sure if I change direction. If I've got a little bug walking on there and he changes, then it's a max or a min. Absolutely. So let's go back. Let's go back to this very first one we looked at. And I'm going to give these just some random points. I'm fixing to show you how to find the points exactly. You're not going to like that, but it's okay. Let's say this was -1, I don't know, 7. Let's say this is 5, 2. Describe the increasing and decreasing intervals of this graph. All right, let's see. You always go smallest to biggest, just like you do with everything else, with all our interval notation, right? I find it easier sometimes. Go ahead, Gracie. It also asks you domain and range. Left to right for increasing, decreasing. It's bottom to top for range. All right, so no, they're not the same. Okay, we'll do them in just a second. We'll do them. No, when we put everything together, it does start getting confusing on what's with what. We'll do one full-on analysis from start to finish with everything. All right, I sometimes tell students if you start getting confused, label your graph, right? I've got increasing, what is this little area? Decreasing, and it's okay. See, it kind of doesn't decrease as fast, but it's still decreasing nonetheless. And then increasing here. So always start with the furthest left. From negative infinity until right here, I need to describe that. How would you do, that's increasing, right? How would I describe that? Negative infinity to negative 1. Then what happens? Bless you. It decreases from negative 1 to 5. So I'm going to go down to the decreasing one, and I'm going to say negative 1 to 5. I'm only using the x's, remember. And now I need to pick up that last interval. That's right. So I'm going to come to increasing. Now, if I need to add something else to it, how do I do that? With a u. That's exactly right. And I'm going to do 5 to infinity. And there's my increasing, decreasing. Yep. Yep. All right, take out your calculator because here's where it gets real. What don't you understand? Why do I put the 5 what? Yes, yes. Right. It actually stops right there. He's not increasing or decreasing right there. He kind of stops and changes direction. But that's okay. The U combines those intervals. This says this is increasing, but also this is increasing also. Okay, so the decreasing is only happening right here in the middle, right? That's between negative 1 and 5. So that's why I got that. All right. Okay. Tell me when you're ready. Pre-cal is still doing analysis like this, but we got more steps in it than what y'all have right now. It never goes away. Calculus is doing it too, but woo, their functions are a lot different. There's one more on my desk. Tell me when you're good. All right. I'm going to run through a full-on analysis with you start to finish, but I'm going to have to take some time on how to calculate these things. So y'all stay with me. So this is what the second part of your homework looks like also. And so you see I've got this function, right? And I'm asked to give all this different stuff. I'm asked to give domain. This one's not on your sheet if y'all are looking. I'm asked, you only have like 4, so I didn't want to do one of those. I wanted you to have plenty of practice. I've got to give domain, range, the maximums, and they say relative. That's one of those things. Everything is relative, but not everything is absolute, right? It's kind of like the square and rectangle thing, because they're always going to be the high or low in their vicinity. So I just ask that you make a note if it's absolute and put a star or something back and say this one's absolute or something like that. But all the maxes and mins, the end behavior, and notice how the first part of the sentence is written out for you, because yesterday we talked about that's always the same, right? And we're just looking for these two ends. And then increasing intervals and decreasing intervals, okay? So I need to show you how to do this on your calculator because I'm not making you do this by hand, and then show you what I expect as you graph it, okay? All right, So notice my equation here, negative x cubed plus 3x squared. So let's take out your calculator. Have to make that noise when you do it too. I can always count on you. Yeah. Hit y equals, make sure everything's cleared out. Make sure none of these plots are highlighted. Okay, if they're highlighted, they will look like that and you will not be able to graph. So go up to them, hit enter, and come back down, and that cuts them off. No, not this one. Everybody with me? All right, let's type this equation in. Negative, and make sure you use the negative that's under the 3 and not the minus sign, or you'll get an error. Negative x to the third power plus 3x squared. Some of you have newer calculators than me, and it gives you, it formats them a little better, but X is the button right beside the green alpha button. And then I want to do a zoom 6. So zoom 6. Zoom 6. That's how we're always going to start. Zoom right up here at the top beside window. Yeah. No, we're not even going to make a table. We're going to look at it first. All right. It looks like, huh? Yep. All right, here's the part where you're going to get confused, so I need you to stay with me, okay? Okay. We are going to let the calculator find the maxes and mins for us, okay? But wait, you got to stay with me. You got to pay attention, okay? You've probably never done this. I'm assuming by your looks you've never done this before. Second, trace, okay? Notice option 2 says 0. That's where it crosses the x-axis. Option 3 is minimum, and option 4 is maximum, okay? Remember what that graph looked like? I'm going to work on this point first, so I'm going to choose what? Minimum. So second, trace, and I'm going to choose number 3, minimum. All right, remember I was talking to you about my little bug? Here's my little spider, my little bug. See him blinking on my graph? All right, look at what it's asking me. Yeah. Left.
It'll ask you a question.
Second trace. Okay. Here's what it's asking you, and let me try showing you first before I show you how to do it on here. It's asking you, it's going to ask you for these bounds, and what it's doing is your calculator will only find a low spot between two values, okay? It's not going to look at the whole graph and find an absolute. It's going to say, give me a range to look in, okay? And so what it wants is, if I'm finding a minimum, and I want to find this point right here, well, it needs to know, where do you want me to look between to find a low point? So it'll say, what's a left bound? So I need to go to the left of that point and give it a boundary. This might be my left bound. And then it'll say, what's your right bound? Because it wants to know how far over to the right. And I'll give it a right boundary. And then what it'll do is it'll calculate between these two values the lowest point, okay? So that's what it's trying to do. So here's what I'm going to do. I'm going to go back to my calculator. And for left bound, I'm just going to take my spider and I'm going to hit left until I'm sure it's to the left. Remember, I need to give it a range of numbers to look. And I'm going to hit enter. As soon as I hit enter, it pops up and says, what's the right bound? So it wants me to go to the right side of what I'm looking at. So I go to the right until I'm sure I'm past it and I hit enter. And if you look, do you see these little arrows that are up top? Those are those little bounds I was talking about. So what my calculator is telling me now is, if you want me to find it, I'll find the lowest point between this arrow and this arrow. Well, yeah, I know my minimum lies between those two, right? So I'm going to hit enter because, yes, I want to guess what that point is. Actually, okay, now this is scientific notation. Your calculator is pixelated. It runs a program to find the minimum that involves derivatives and everything else, and it gets off by a little teeny tiny bit. If you ever see this, if you see E with a negative number, a big negative number like this, it's 0. Okay, so this is 0, 0.
Yeah, I got 7.68.
Does it have an E followed by a negative number? Then it's 0. Okay, that's that itty bitty teeny tiny little decimal. Yeah. Does it have an E? It's running a program to calculate the minimum value, and in order to do it, it's truncated or rounded at some point off and it causes it to be off. I mean, that's so little. That's really 0.00006.
So like if it's within like 0.1 or 2, it's not
well, you won't even be that much off. It'll be within like 0.00001. Okay. Yeah. She's real good with the calculator. She's good.
No, she needs to turn the brightness up and down.
Oh yeah.
Yeah.
Just hit second up or second down.
It's real hard on it too. Like,
Yeah.
she'd be like, I lost it. Yeah.
All right. So my minimum here, 0, 0. I'm going to go over here to my graph, and I'm just going to put a point at 0, 0 because I know that that's my minimum, and I'm also going to come over here and write that I have a relative minimum at 0, 0. And it is relative. It's not maximum. It's not absolute. There are no absolutes on this one because it is. Somebody keeps pushing like over and over again. Let me go right here because that's distracting. Harris. Can I what? Well, that's not your homework. This is just another example.
Oh, so we use a calculator to get our points.
That's right. That's right.
I was wondering why we have calculator.
I'm fixing to show you. So all I've done is that minimum right now, right?
So on the test, we can use
Yes. This is strictly calculator.
Are we allowed to add? Are we allowed to write down like the correct button?
No.
what?
So you better.
Yeah. All right, let's go in and calculate this maximum, okay? Second, calculate max. Now, watch. This is always where students mess up, so pay attention. Left bound. Watch my spider. He's traveling. He's right here, right? Remember, I got to give him a range to look in, so I'm going to make it somewhere between here and here. It doesn't really matter how far over as long as you're to the left and then you're to the right. So left bound, I'm going to make sure I go to the left some, and then I'm going to hit enter. See my little arrow that popped up there? And now I want to go to the right, so I'm going to hit right. Now my question is, if I look in between those two arrows, does my maximum fall between those two arrows? So I'm good to guess, okay? You'll get an error if it doesn't, and it'll say, oh, I can't guess, I don't have anything there. But it does, so I'll hit enter. My minimum, again, be very careful about what the calculator is giving you. This is going to round to what, bless you? 2, 4. Bless y'all. 2, 4 is my maximum. I'm going to label that on my graph. Okay? Yeah. All right, second trace. I'm choosing maximum. And I'm going to the left. And then I'm going to the right, and I'm going to hit enter. Nope, as long as you give it a correct interval. You don't want to cross over to another. Sometimes you have multiple, maxes or mins. You don't want to go so far over that you cross over another one or anything, but yeah, it doesn't matter. Sometimes with my kids that are having trouble understanding, I'll tell them to put the spider on the point they're trying to find and click left 3, and then put it back and click right 3. But there's no set number of times. Just scroll back over. All right, let's talk about what we need to graph this. I would tell you, this is not on there, but I would like for you to find this so that you can put it on your calculator. This point right here, remember, we've done zeros with quadratics, right? We did, that's where it crosses the x-axis. We're going to do that same thing here. If you do second trace and you choose 0, I really want to find every place that it's crossing because I want as accurate a graph as I can without being like overly accurate. So I chose 0 this time. I'm going to do the same thing, just like before. This is the 0 or where it's crossing, and I need a range, right? I need a left bound. So I'm going to go to the left of the 0 and hit enter, and I'm going to go to the right of the 0. Does my 0, or where it crosses the x-axis, fall somewhere between those two arrows? So hit enter, and it gives me that point. That gives me a good point to come over here on my graph and say, okay, I know 2, 4, 2, 1, 2, 3, 4 is a maximum, and then 3, 0. Now I should have enough information that I can come in and I can kind of sketch a graph from this. Okay, and now I have a good graph, a good estimate. Doesn't, other than maxes, mins, and zeros, and then you just connect them. No, it doesn't have to be exact. What is the domain of this? That's exactly right. How about the range? Negative infinity to infinity. I've got my maxes and mins. I already did that whenever I calculated, right? So now, how about in behavior? As I approach positive infinity, so on the right side, what is the graph doing? It's going down, right? Negative infinity. How about as x goes negative? It's going up. It's positive. That's exactly right. And then the new part here, or the other new part, my increasing and decreasing intervals. So from negative infinity until 0, is that increasing or decreasing? So negative infinity to 0. Then what happens? From 0 to what? 2, right? Because I'm using those x values only. So from 0 to 2, is that increasing or decreasing? Increasing. And then 2 to infinity is doing what? Decreasing, so I'm going to hook it on here. It won't, but if you happen to have one, just come over here and write absolute and then put the point. Huh? 2 to 0. There's a point, but it's still decreasing. I'm still going down. I'm going down forever, so it's always increasing. It doesn't stop decreasing. You're looking at the x. You're talking about where is it decreasing. It's decreasing all the time. Left to right, yes. Always looking at x. Amber, what was your question?
It looks like the odds like in here is always going to be within.
Yes, yes, that's exactly right. That's a great point, yeah. Yeah.
Is it not increasing?
As you move left to right, the same way you read a book, is the graph going up or down? Yes. Well, yes, even though there's, because I'm moving left to right, so I have to come in this way. So as I come in this way, it's dropping. Because I'm always going to start with negative infinity when I'm doing increasing and decreasing. Because that's as far left as I can go is negative infinity. And then I go until I get to my first max or min. This, yep, this is negative infinity to 0. X's only. You're looking at your X's. So as I come in this way, this is negative infinity, right? This is when X is 0. For your X, you're looking at X, right? Yes. All right, I'm going to let you get to work. Some of you are already working very fervently.